Welcome everyone. My name is Andrew Anderson. I am a Field Applications Engineering Manager with Micron. My team in EMEA covers industrial and consumer markets for technical support on the sales side. We have other people who cover different market segments. Today I'm here to talk to you about memory and storage innovations, accelerating intelligence at the edge, and hopefully you'll find something interesting in this presentation. For those of you who don't know about Micron, where have you been for the last 40 years? This is a quick overview of the sort of company that I work for. 48,000 employees, the fourth largest semiconductor company in the world, $30 billion revenue last year. Quite a substantial investment in manufacturing sites with 11 sites and 15 customer labs spread throughout the globe. I don't know if any of you were listening to Nigel Watts earlier from WPG, who was talking about the balance of investment in manufacturing between East and West. And he mentioned the fact that the US are putting more money into manufacturing going forward to try and counteract the shift that's been towards Asia for so many years. I thought I'd make mention of that because Micron recently announced a major investment in New York. We are building a mega fab specifically for DRAM in New York and expecting to invest about $15 billion into that fab by the end of this decade. It'll be a world-class facility. At the moment, most DRAM is manufactured in Asia, but thanks to political situations and what have you, we're being encouraged to expand in our home base of the USA. Obviously, I'm not American, but we have sales and other people all around the world supporting many customers. In EMEA particularly, we have a large industrial automotive base, which may not surprise you. And I personally don't work in the automotive space. I have other colleagues who do that. But there's a lot of commonality in the products and the quality and the labs and all the other stuff that happens between the automotive and industrial segments. In Micron, we like to think of ourselves as being on the high end of the quality spectrum when it comes to these essential devices that you find in just about everything these days. So what is the intelligent edge? This is something that, from a Micron point of view, we think of as it's a growing set of interconnected systems at the physical network edge where data is analyzed and aggregated close to where it is generated. So rather than having data sent a long way away to some kind of data center where it's processed, the intelligent edge moves that function closer physically to the endpoint where the data is aggregated. And here we have an example of the sort of things that we see growth in the intelligent edge, which previously may have been much more simple devices that didn't do very much in terms of trying to make sense of what they were acquiring. Video security, smart home automation, etc. You can read them there. And as you say, billions more connected devices. It's no surprise that there are billions of devices connected to some kind of network these days, and the year-on-year growth is quite outstanding. So it's important for us as Micron, who supply devices that are used in just about everything, that we understand what's going on here and we develop products that can address this market. One of the key aspects of this moving forward will be 5G communications. A lot of systems have been using 4G for many, many years. And in the 4G architecture, the data is generated and then transferred across the network to the cloud, not particularly in real time, and processed there, and then eventually some results come back. That latency can be a big issue in some applications. 5G gives an order of magnitude improvement in latency and bandwidth, which allows for the 5G network to be more like an integral part of the whole data processing and analysis subsystem, instead of being some kind of offline batch process type of scenario. So even though there is much more bandwidth at 5G, with the growth of the intelligent edge, there is the potential to actually do a lot more analysis and aggregation at the edge, and actually less traffic over the network than you would have with a traditional 4G system. I'm going to look here at the use case of autonomous machines. This is one of the early adopter areas for this kind of application here. Either guided vehicles or autonomous robots. These are systems that have some kind of built-in machine learning and intelligence and interact with each other in an automated way. One statistic I have is that Amazon, for example, in 2020 installed 250,000 autonomous robots into their warehouses. 250,000 robots in 1 year. And they're obviously a very large organization, but this kind of idea is going to filter down to many other organizations. We're seeing it in healthcare, we're seeing it in retail, we're seeing it in lots of other areas. This is where things are moving in the future, and the growth is quite stunning. So if you think about what sort of things go on in these intelligent endpoints and these edge processing, you think of LiDAR, for example, which a lot of them use to detect the distance to objects in their field of view. There's a distance attribute for every single picture, every single pixel that they see, and it has to make sense of that in real time. Just think of the processing and think of the amount of data moving around to do that, and what implications that has for the architecture of what previously might have been a fairly basic router that just sent data to a cloud and got a result tens of seconds later. No, this has to be done in real time, and that's where the memory and storage architectures that are needed to support this kind of application are absolutely critical. So I have my little crib sheet here. So apologies for this, but when we look at the memory architectures that are going to support that kind of thing, if you wind back several years ago, you would have never considered using low-power DRAM in anything other than a mobile phone. Right? Everything was based on the same sort of memory you get inside a computer. It's kind of turned on its head now. Low-power DRAM is enabling these intelligent endpoints, and it's working its way further and further into high-performance computing applications for a number of reasons. Here we've got a chart showing the sort of capability that's needed and that's possible now with the latest low-power DRAM technologies. Between the intelligent endpoints, where built into the sensor or the robot or whatever itself, you've got some computing to the edge, the intelligent edge at the customer premises, so geographically close to where the data is gathered, to the infrastructure, that's where it's gone off to the cloud for processing. And you can see that as you go up this chart, you get more and more capability in terms of performance, and we have the sort of memory solutions that we see in the short term as being appropriate for each of these applications. LPDDR4 and LPDDR5 are the sort of bread and butter of a lot of industrial applications these days. It's where you get the best performance, and you can see the sort of speeds and bus widths that are needed. If we look at the technical benefits of each of these technologies as we go up through the years. You can see the data rates are improving, as you would expect, but also the power is going down. And that's critical because so many of these applications are constrained by thermal considerations or battery-operated vehicles that have a limited amount of time on a charge. You want to reduce the power consumption. And here we're talking about milliwatts per gigabit per second. Quite a dramatic decrease as you go through. And this is why companies like Micron work within JEDEC to define new standards every few years to improve the way the memory works. As our process technology shrinks, we get greater capabilities to do things that weren't previously possible. Some customers in the industrial space, of course, find this irritating because they have to keep redesigning stuff. They can't buy the parts they used to buy, etc. But there's a very good reason for it, and it's to serve this demand, this growing need for all of these autonomous systems, these increasingly intelligent systems, to do things that weren't previously practical or affordable. Micron is uniquely positioned to serve the industrial market through what we call our industrial quotient value proposition. We are one of the big three memory manufacturers in the world. There's no doubt about that. We have a significant market share, but the areas that we excel in, the areas where we have the number one position, are the high quality end of the market, the automotive. We've been number one in automotive for many, many years. Networking infrastructure, where reliability is absolutely key, and industrial, where we have a number of different things that we bring to the table. Product longevity. Yes, we are at the leading edge. We are bringing out the latest memories as early as anybody else. Sometimes we're ahead of everybody else. We're the first ones to market with, for example, 176 layer 3D NAND. We were leading the market with that. We were one of the first ones to get LPDDR5 into the hands of users when that first came on. It's been in the market a while now, the LPDDR5, but we were right there at the beginning. But despite that, because we recognize the value of industrial applications, we also support the older technologies with a longevity program, which means that you can still get the older technologies with a longer lifespan and longer notification of end of life than you would get in some of the other competitors of ours who focus purely on the latest technology and have a nasty habit of end of lifing things at very short notice. So that is part of that is down to our huge presence in automotive, where design life cycles are many, many years, and they require continued production for many years afterwards. We have, as I alluded to earlier, we've got many different factories where we manufacture silicon, some in the Asia, some in the US, and increasingly more in the US, as well as the mega fab in New York that I mentioned at the beginning. And I see Nigel has now joined us, and I want to thank you, Nigel, for talking about the Asia-America's balance, because it reminded me to talk about our new mega fab in New York. We're headquartered in Boise, as I said before, and we are also building a fab in Boise to build. We have a small R&D fab there now, but we're making a massive expansion to the clean room there to develop newest products. So, and one of the other fabs we've got in the US is in Virginia, and that is pretty much dedicated to these longevity programs. So the slightly older technologies that are required for automotive and industrial applications long term, they're built there. So yeah, we've got this. It's not just like we build them when there's nothing else worth building in the fabs that put out the new products. We've actually got a dedicated facility for doing that to support customers long term, and we've been doing that for many years. I've been with Micron 12 years. Shortly after I joined, we introduced this longevity program with a promise of 10 years longevity on a whole range of different products. And I have actually been here long enough to see it go all the way to the end of that 10 years, and we kept that promise. So it's quite encouraging for people who maybe don't have the resources or maybe have very long certification cycles, for example, in the medical field or the aerospace field, where you need several years to get your part approved before you can start selling it, your end product. You want to be partnered with somebody who you can trust to keep supplying the parts you need to build it when it finally does get certified. And that's one of the value propositions Micron brings. Allied to that is ruggedized products. We have a broad range of temperature and quality variants. For example, if you look at LPDDR4 or LPDDR5, we have a range of products that are put into mobile phones. And then we have another whole range of parts that are designed for automotive and industrial applications. Now, it's the same die inside, but what's different is it's a different package. It's thicker. It's got a different redistribution layer with bigger solder balls. And that's there to keep it performing well in an application that has high temperature cycles, vibration, and shock that you wouldn't get in a mobile phone application, right? So not every memory manufacturer would go to the bother of creating a whole new part just to serve that specialized market. But again, because we've got the huge presence and the legacy of supporting that market is worth our while to make those specific products to support. High reliability, again, this comes down to if you buy the higher grade parts from Micron, they will have gone through a completely different quality screening process in our fab where we can get down to single digit DPM. And that can be very, very important in applications where the cost of failure is huge. Obviously, they cost a bit more than the basic version, but the total cost of ownership when you get so few field failures can make a huge difference to your business. Allied with that is the extensive quality testing that we do for those products and for all products for that matter, process monitoring, etc. We are. I don't know what I can say that's not confidential, but let's put it this way. This is something I read just yesterday, but I haven't had time to figure out whether it's suitable for public view. But suffice it to say, with some of our customers, we are regarded as the leader in quality amongst all the suppliers they have for memory. So I think that's probably about as much as I can say. Sorry for being so vague. And the final point here is application-specific optimization. We either develop products or develop variants of products that are that suit particular applications with specific needs, and that can be very useful. For example, you may find that there's a Micron part that has a slightly different configuration available that nobody else offers, and that's because we've developed that for a specific use case at an end customer, and then it's available to the wider market and may serve your need where others don't. The other thing that I want to talk about with industrial quotient, I want to touch upon security. We have a product which is in our flyer, which is called Authenta, and what that is a TPM, which instead of being a piece of logic is built into a piece of non-volatile memory, as well as the hardware root of trust, and it's got all the various certifications, etc. Zero-touch onboarding, root of trust right from the very start of boot. that is just the first part in a whole ecosystem of a sort of cloud-based authentication platform that we can build up. And the key differentiator with it being based in the memory or the storage rather than as a piece of logic is that it's hardware agnostic. Because every single piece of hardware has some kind of flash memory in it, right? So if you're deploying onto a platform and you want the ability to switch to another platform without having to completely redesign your entire authentication system, well, you know what? It's going to work in any system that has got a flash memory in it. So I didn't want to go into too much detail here today, but if you're interested in that kind of solution, you can talk to us. So let's move on. So let's go back from Micron's industrial quotient, Micron's value proposition, and start talking about connectivity and the evolution of connectivity over the years. In the old days, you had sensing, and then you had stuff sent to a data center where good stuff would be done to it. The IoT edge is the new thing that's coming in between this. And this is where you get data aggregation, normalization, inferencing, machine learning, inferencing engines, and sometimes even a bit of on-the-fly training. And you know, the 5G interface would enable that because there'd be a much lower latency interaction between the training model in the data center and the IoT edge. So the model can develop in real time. And local storage. Clearly some systems in the past would have been entirely local storage with no network connection, but they have obvious disadvantages, not least of which is your data's not safe if something happens to your location that you're at. So yeah, that's what the intelligent edge does. It bridges between the endpoints and the cloud. And when you look at this, you can see that every single point along this spectrum of it's something that would need memory and would need storage. So let's look at the requirements for that. What do we need to support the intelligent edge? Well, this is quite a busy slide, but it's got three main parts. You've got what function is the edge supporting, right? At the very base level, it needs to be secure, it needs to have authentication, and it needs to make sure that when it connects, it's something you can trust. Then you've got code and data storage, you've got data aggregation with connectivity, and then you get into the more intelligent bits of the puzzle. You've got the compute and analytics, you've got a whole load of microservices that can run on the edge and applications. You've got all of these sort of ever-increasing complexities of function that an edge device can support. What sort of memory do you need? What sort of storage do you need to make that a reality? You've got a heterogeneous mix of memories because there are so many things to choose from that we produce. There's the LPDRAM that I spoke about before, the LPDDR4, LPDDR5, but then there's also the sort of module-based traditional DRAM you may find in servers, and a lot of edge systems would use that as well, either soldered down if it's a small form factor or as a module. Then when it comes to the storage, there's a whole range of different storage options to consider, from very basic NOR flash or NAND flash, but mostly these days you're looking at managed NAND of some kind, and that's everything from an eMMC all the way up to a full-blown SSD with huge bandwidth and many other things in between. The things that the memory needs to do, the memory and storage products need to, the features they need to provide in order to support a capable intelligent edge that can do these more advanced functions. Things like if you look, I'll start top to bottom. We talked about the industrial focused portfolio. We talked about the longevity on the previous slide. That's quite important because sometimes these edge systems will be, for example, in a factory for many, many years. You want to be able to maintain them. You want to be able to keep supporting them long term. The intelligent partitioning, that refers to the fact that modern SSDs can have multiple namespaces that operate independently of one another. So if you're running multiple applications on your edge server, a single SSD can sort of be virtualized at a local level and support them without interference. High performance wide bus enables real-time analytics. So going back to the earlier slide where we looked at the bus width and the bandwidth of each of the memory devices, that gives you a certain amount of data that you can process. People often think of, well, you know, how many cores, what frequency can I run at, how much processing power do I bring to the table, whether it's a general purpose CPU or a GPU or a TPU. But actually, unless you've got a nice big fat pipe to a big amount of DRAM, you're going to be limited by your memory, either in terms of how fast you can get the data in and out of it, or even how big of a model you can support, right? The bigger your model, you know, whether it's a TensorFlow or whatever kind of model you've got for inferencing, the bigger it is, the better results you're going to get, the more accurate decisions it's going to make, and the quicker it's going to make those decisions. If it has to keep paging bits of the model in and out of a storage device, or if it's got a reduced model because it doesn't have the storage for it, you're going to get worse decisions, slower decisions. So if you're thinking about an architecture, don't just focus on the processing. Think about where is your bottleneck going to be, and often you find out it's actually in the memory. Yeah, supporting leading interface standards. Clearly, as I said, there's this evolution of technology, the relentless march of technology, you know, from all the different generations of DRAM. Pretty much DDR5 and LPDDR5 are what you would use today. Anything else, even DDR4 and LPDDR4, are rapidly becoming legacy. We have stopped releasing new versions of those. We're now at a point where the most recent die revision, which has been in place now for well over a year now, that's as far as it's going on LPDDR4 and DDR4. There won't be any further die shrinks. There won't be any cost reductions in those moving forward. It's all going to be LP5 and DDR5. So think about that if you're architecting a solution today that might be deployed in the field for the next 5 to 7 years. Right? You don't want to be on the trailing edge. Similarly with the storage, as I said, our latest eMMCs, SSDs, micro SD cards, UFS, which isn't mentioned there, they're all 176 layer 3D NAND. Moving on, we've just recently announced 232 layer NAND, which will be products will be coming out soon. It's this relentless march, and the capacities get bigger and bigger and bigger. But if you want to be a capable and competitive system in a couple of years' time, you've got to be right on that leading edge. This is another slide which talks to the way things have gone over the years. And this is interesting. This is talking about multi-core CPU architectures. As I said, you know, the more cores you've got, the faster the memory bandwidth you need because it's shared out. If you look at this chart here, apparently this is a laser pointer. I don't know how bright it is, but you can see from the year 2000 to 2019, there's a sort of arms race going on between how much bandwidth you can get from the memory and how many cores you've got in your system. And then down the bottom of this little blue line shows the bandwidth per core, which is pretty much flatlined and actually begun to dip down a bit compared to 10 years ago. And this is a problem, right? You can have all the computing power you like, but if the cores are sitting there waiting for access to the memory bus, it's just eating power for no reason. So again, DDR5, here we're talking about modules, DDR5 modules. Even at the same speed, the 3200 speed, the effective bandwidth on DDR5 is a big increase because architecturally it works better. And then, of course, it does support a higher bandwidth, so it's nearly double. Nearly double. Okay, I'm at half past. I'm going to now move on to another application. We talked about the industrial automation, the autonomous robots and things. Now we're looking at video security and VSAS as a different application. We estimate by 2030 this market will be worth $83 billion globally. 10% growth rate per year, so that's quite significant. Quick overview of what VSAS is. It's a cloud-based system. So you've got, rather than having cameras and a network video recorder locally, and then backups at some point in the future, hopefully that work, you actually connect your cameras directly to the network, and all the storage and processing and stuff happens in the cloud. Micron offers video-specific micro SD cards for a local backup, because obviously if you lose your network connection at a critical point, that's a disaster. So there are applications where each camera's got a little micro SD card in it that can store a lot of data for many, many hours while you get your network back together, and then you don't lose anything. So video security as a service rather than as a bunch of hardware you manage yourself, it's a subscription-based idea, which offers advantages of remote management, scalability, and a reduced total cost of ownership. And this is the growth area. And what do we have to support this system? Well, I'm going to talk specifically about this micro SD card for a bit, and then we'll look at some of the other memories that are used in these systems. It's important to understand that there's a big difference between a card that's designed for video security usage and just an off-the-shelf consumer-grade card. And we're going to look at why, in some applications, the cards fail. This is quite an interesting chart for those of you of a technological mindset. This is some analysis we did of a typical retail micro SD card versus our one that's optimized for video security. And this is how many hours we're recording, what does it say? Recording video at a specific band rate. I don't think it's listed on here what that bandwidth is, but if you go up to 24 hours a day or even or down, you can see that the lifetime of the card in years for a typical card is quite short. Once you go above about 12 hours a day, it gets to less than a year before it's fully worn out. And that's where what we call our i400, which is our latest generation of cards, can offer many, many years, even at 24/7 recording, high definition video, 6+ years of life. Obviously, it has implications for maintenance costs and for reliability in the case that you do need to rely on that backup. This is another chart that shows more or less the same thing. Consistency of recording without dropping any frames. A retail card, once it starts to get worn, fills up and is overwritten many times, it starts dropping frames because it loses the ability to respond quick enough. We have released a 1.5 terabyte capacity micro SD card for the video surveillance market, video security market. So you can imagine how many hours of video you can store there. And these are some of the specs of that. This performance is optimized for 4K recording and also AI events. So you get, if you've got a camera with some inbuilt intelligence or an edge device with some inbuilt intelligence that can recognize key events that it wants to make a specific recording of, the card needs to be able to deal with that. traffic as well as the basic traffic. So that was all I wanted to say about video security. If I'm talking now about the intelligent edge as a whole, all the different applications, these are a summary of the different types of products that we support the market with. The micro SD cards we talked about, the LPD RAM we talked about, high performance in battery powered devices for energy efficient. So one of the things, if you've never used LPDDR4 or LPDDR5, it has the ability to run the interface in a very power efficient way, because it can go into sleep mode, it can change the clock speed on the fly with every transfer. It can, if it's running in a non-critical way, it's not a high bandwidth demand scenario, it can run the bus much slower, save a lot of power, and then when it needs the extra power, it can immediately speed up. Whereas the sort of memory you get on modules that sit in servers, they're designed to run at one speed forever. Then they're not nearly so good at optimizing the power consumption. The Authenta technology that I talked about before, chip level security, linked to a cloud-based ecosystem that allows remote management and provisioning, zero-touch onboarding, and all sorts of good stuff. Old technology now, but NOR flash memory still has a part to play. We have the standard Q-SPI NORs, but we've also got the thing we call Accela, which is an octal SPI NOR with extremely high bandwidth and critically very fast boot. It's ready within a few milliseconds, and the data comes out. You can, with a very, very simple endpoint, you can do execute in place or all sorts of things with these NOR flash that you can't do with a more sophisticated storage. However, the capacity is obviously limited. The mainstream DRAM, which you will find in cloud servers and things like that, we sell a lot of server modules to the cloud providers, and if that's the architecture you're after. The 3D managed NAND, that would be things like the SSDs, like the MMC, like the micro SD cards. And finally, the automotive grade memories, which, as I told you at the beginning, we've been the number one in automotive memory for many years. So if you want the absolute best quality, we've got those products for you at the leading edge. I think that was my last slide. Thank you for your patience in listening to me. We've got a few minutes left for any questions that you may have. Anybody want to challenge me with a question? Nigel, thank you.
Not a challenge, but a statement, really. I mean, Micron have been in the leading-edge memory business since the early 1980s, and a lot's changed in the memory world in that period of time. Micron's not only evolved with it, he revolutionised a lot in the memory market. If you look forward to the next 10 years, we're going to see an even greater adoption of revolutionary-type technology. Micron, what are the plans to keep pace with that and even spearhead those technologies moving forward? Do you see Micron still being at the head of the curve?
Certainly hope so. Because one thing that you should know about memory is in the 1980s, as you said, there were, I can't remember how many, 40 or 50 different manufacturers of memory, and the vast majority of them went out of business, and there's only really 3 big ones left. Why? Why would that be? Well, it's quite simple, really. Unless you're at the leading edge, you can't build the memory cheap enough to sell it for a profit, right? It's a harsh reality. You've got to be at that leading edge, or you either go out of business because your costs are higher than the market price, and then you're dead in the water, or you go into niche markets where you're building specialized memories in very, very small quantities for a few customers that are willing to put their hand in the pocket and pay a lot of money for something quite unique. And there are a few of those small players around. There are some sort of, not niche, but there are some smaller manufacturers who focus on a narrow product line, whether it be just NOR flash or just DDR3 or something like that. And they kind of come and go, and But if you want to be on the leading edge, if you want to be a $30 billion company with building mega fabs and all the rest of it, you need to be on the leading edge. And we are an integral part of the JEDEC committees that define the standards for all of these all of these memories. We sit down next to our competitors and our partners who make the controllers that interface to those memories, and we are instrumental in making those definitions, and long may it continue.